Next topic is electromotive force. What is EMF? EMF is the potential difference between the positive and negative electrode of a cell when the circuit is open. EMF can be calculated by using the relation work done by charge. The unit of EMF is volt or joule per coulomb. Next, what is terminal potential difference? Terminal potential difference means it is the potential difference between the terminals of a cell when the circuit is closed. The terminal potential difference when the cell is in discharging mode. When the cell is in discharging mode, the terminal potential difference can be calculated by using the relation V is equal to E minus I into R. Here E represents the EMF of the cell, I is the current and R is the internal resistance. And at the same time, in charging mode, we can write the terminal potential difference V is equal to E plus I into R. So when the circuit is in discharging mode, we can write the terminal potential difference V is equal to E minus IR. When it is in charging mode, we can write the terminal potential difference is E plus I into R. Here there is a difference between electromotive force and terminal potential difference. The first point is electromotive force means the potential difference between the terminals of a cell when the circuit is open. Terminal potential difference means it is the potential difference between the terminals of a cell when the circuit is closed. And the second important point is the electromotive force is independent of resistance of the circuit, internal resistance of the cell and current in the circuit. But at the same time, the terminal potential difference depends on the resistance of the circuit, the internal resistance of the cell and the current in the circuit. Next topic is internal resistance of a cell. What is internal resistance? Internal resistance of a cell is the resistance offered by the cell when an electric current flows through it. This internal resistance depends on four factors. The first factor is nature of electrolyte. Nature of electrolyte. And the second factor is nature of electrodes. And the third factor is distance between the electrodes. And the fourth factor is area of cross section of the electrodes. So internal resistance depend on four factors. The factors are nature of electrolyte, nature of electrodes, distance between the two electrodes and the fourth one is area of cross section of electrodes. So next we have to derive the relation for internal resistance of a cell. So here you just consider a circuit. Here we are considering a cell. The EMF of the cell is E and the cell has a resistance. That resistance is taken as small r. That is said to be the internal resistance of a cell. And this cell which is connected to an external resistor. The external resistor which is taken as R. Let I be the current flowing through the external resistor. The direction of current flow is from positive to negative. So if the cell is connected through an external resistor, there is a discharging of electric current. So that during discharging, the terminal potential difference can be written as V is equal to E minus I into R. So here we can write I into R which is equal to E minus V. From this equation we can write R is equal to E minus V by I. This is one relation. And the second case you can write if V is equal to I into R, we can write IR which is equal to E minus I into R. Then the same equation we can write I into R plus I into R which is equal to E. I if we take common, we can write R plus R is equal to E. From this relation we can write the current I is equal to E by R plus R.
If you found this video helpful, please like, share and subscribe to the channel. See you next class.